Welcome back, everyone. Let's do a little bit of review before we jump into new content. Remember, this is a logic course. What is logic? It's the study of correct reasoning. Philosophers care a lot about arguments. Good arguments contain reasoning that is good. What is an argument? It's a set of statements. It has two parts, namely a conclusion and premises, at least one or more. The premises, their job is to support the conclusion. The conclusion is like the structure on a foundation, and it's the job of the premises to provide support to hold that structure in place. The conclusion is alleged to be supported, and the premises, their job is to do the supporting. At the end of each chapter of our textbook, there is a nice review of all of the central concepts. So if we go toward the end of chapter 1, there's a summary here that covers all of the basic concepts. Logic, the study of correct reasoning. Or we could put it this way. This is the way that the author of our textbook defines it, which is also a perfectly fine definition of logic. It's a science, in a sense, that evaluates arguments. It helps tell us which arguments are good and which ones are bad. Argument, a group of statements that has premises and a conclusion. The premises are the statements that are alleged to be the reasons or evidence in favor of the conclusion. And that's the statement that is alleged or claimed to follow from the premises. And last time we looked at special clue words or indicator words that are signals to us that a premise or conclusion may be nearby, like the words hence and therefore. They indicate a conclusion since and because those are premises indicators. All right, let's jump into new stuff. I want to start by comparing two arguments. Here's one that we already looked at before. Again, a not very interesting argument, but we'll use it to make a point. Premise: I, Ryan, live in California. Conclusion: therefore, I, Ryan, live in the United States. And of course, we're talking about the California, one of the 50 states. It's California is in the United States. That's an implied premise. But the short and sweet version is right here. So think about the logical relationship between living in California and living in the United States. Just think about that for a moment. Compare this argument to this one. Premise: someone named Mary doesn't live in California. They live in Florida. Conclusion: this person, Mary, has seen a Florida license plate. Now, you can pause the video in a second and ask yourself, what major difference do you see between these two types of arguments? And after you've thought about it, you might come up with an answer that, well, the conclusion here seems better supported. In other words, there's a logical guarantee, isn't there? Living in California, the California that's in the United States, guarantees that one lives in the United States. However, we don't have this necessity, this logical necessity in this Florida argument. However, what we do have is a high degree of probability. If somebody lives in Florida, there's a very, very good chance that they've seen a Florida license plate. But notice the odds, in other words, are not 100%. And why is that? Well, because it's possible to live in Florida and to have never seen a Florida license plate. Think about how this could be. Maybe Mary hasn't seen anything, let alone a Florida license plate, because Mary's eyes don't work. They don't function. Mary might not be able to see. She might be blind. Maybe Mary is the name of a newborn, and this newborn was born in Florida, and I guess a few seconds after you're born, that's where you live. But that newborn, have they seen a Florida license plate? I don't think so. But the odds are still very, very high. So the support that is contained in this argument is probabilistic support. In other words, the odds that the conclusion is true if we grant the premise or premises is high. And the benchmark will be over 50%. The closer you get to the closer you get to 100, the better. Now, with this argument, if we frame it in terms of probability, the odds would be 100%. That's a logical guarantee. If you live in California, then it's 100% that you live in the United States. And that difference between a conclusion following with absolute necessity and a conclusion not following with a logical guarantee, that's the difference between deductive arguments and inductive arguments. Deductive and inductive. So the deductive ones, those are the ones when they work, they logically guarantee their conclusions. In terms of probability, the odds are 100% that the conclusion is going to be true, given that the premises are true. So this argument here is a deductive one, because given that I live in California, and I do, by the way, like many of you, it does guarantee that I live in the US. However, this Mary, Florida argument, it's not deductive. It's not going for that perfection, you will, that perfect inference, let's say. Instead, it's going for a high degree of probability. It's not a deductive argument. It's a good inductive argument because the conclusion is supported with a high degree of probability. So that's the difference between deduction and induction. And here are some technical definitions. Technically, an argument is deductive if the conclusion is claimed to follow necessarily from the premises. So that's that absolute guarantee, 100% support. Now, there are bad deductive arguments. So that's why we have this claim to follow part. If we tweak this a little bit and we said, Ryan's thinking of a shape that has 6 sides. Therefore, Ryan is thinking of an octagon. You might say, well, it was an attempt at a deductive argument. Just the person got confused about what the name is for something with 6 sides versus 8 sides. They got hexagon and octagon mixed up. But the claim, if we almost have to look at the intent of the person that is advancing the argument, but that's what they were going for, it seems. Inductive argument, technical definition. An argument is inductive if the conclusion is claimed to follow probably from the premises. So not necessarily, but probably. And what do we mean by probably? Well, the odds are less than 100, and that's it. And if it's a good inductive argument, then the odds will be between 50 and 100. And again, when I say between, I'm not counting 100% and I'm not counting 50%. So the odds have to be any degree more than 50%. So 50.000 whatever 1% would be fine. 9.99% would be fine. Those would be good inductive arguments. Now, there are bad inductive arguments where the conclusion is only established by, 40%, 30%, 20%. The worst of inductive arguments, the conclusion would follow by just a tiny, tiny amount. Maybe you can argue even 0. All right, let's practice a little bit with figuring out the difference between these 2 argument types. So we're going to go to the textbook and we're going to go to 1.31. And remember, the syllabus, that's your guide for your homework sets. So in another video, I went over a bunch of these questions. And in this video, we're going to start to go over these ones. So I'm going to skip over 1.2 because that's optional, but recommended. So let's look at section 1.3 in the book on deduction and induction. And let's go to subsection Roman numeral 1 and look at some of these problems here. Okay, so we want to go to 1.3. Here it is, deduction, induction. So hopefully you did this reading. And let's go down to 1.3.1. And what's our job here? We need to determine whether the arguments are inductive or deductive. You know, we're doing our job to give our best guess. So there can be arguments where there's a little bit of an epistemological issue. Remember, that's a knowledge issue where it might not exactly be clear, and that's okay. A lot of arguments, it's going to be obvious, and those are the ones that we're going to focus on in this video. Sometimes it's not so obvious, but that's okay. So what I've done here in my digital copy of the textbook, is I've highlighted all of the problems that you will have to turn in your homework packet. And then the ones that I've circled, those are the ones that we're going to do together. So like, what about the ones that aren't highlighted? Well, those ones you're not going to be responsible for. Like number 1 of this problem set, that's not a part of the set. So you start with number 2. Now, what about number 4? Well, you have to do number 4, but we're not going to do it together. So what I'm saying is, just by watching these videos, you're going to get a jump start on your homework. We're going to do a chunk of the homework together. For many, the vast majority of all the problem sets. So I think that works well. So I go over the content, kind of do the mini lecture that we just finished, we'd say. And then we practice together, and then you practice on your own. And hey, learning, wonderful. Okay, let's go through some of these. This problem here is about the Leaning Tower of Pisa in Italy. The plaque on the Leaning Tower of Pisa says that Galileo performed experiments there with falling objects. It must be the case that Galileo did indeed perform those experiments there. Now, right off the bat, this is an interesting one, and I think it's a bit of a tricky one. And it's tricky because this phrase, "it must be the case," that might sound deductive to you. But if you think about how much support the premise here provides, it turns out that it doesn't give us 100% support. It doesn't guarantee the conclusion. So first you have to figure out these are all arguments, by the way. So in another exercise, you're given passages. Some are arguments, some are not. So that was the optional exercise. All of these are arguments, so you don't have to worry about that. You do have to figure out what the conclusion is. Well, the conclusion in this one is the second statement. And this phrase indicates that if something at least allegedly must be the case, why are they saying that? They're saying that because of what they just said, the statement that immediately, preceded that. So this is the evidence or the premise, and this is what we should conclude. But must we conclude it? That's where it gets a little bit tricky. Well, think about it. Just because a plaque on some historic tower says something about Galileo, does that logically guarantee that Galileo actually did what the plaque said? No. Maybe someone as a prank, made a plaque that looked kind of official and formal, and what they wrote on it wasn't true at all. Or what's more likely is that if there is this plaque, maybe the historians did the best job that they could, and they really believed that this is where Galileo did these experiments. But plaques and historians can be mistaken. They're not perfect. They're fallible. And so this is an inductive argument. It's not 100. Maybe there's a very, very good chance that he did these experiments, but is it guaranteed? No. So number 2 here, we are going to say, oh, we're doing part 3 here. Got to make sure we get this right. 1, 3, 1. Here we go. 1, 3, 1. Yeah. So we're up here. So this is inductive. And if you want to categorize what kind of inductive argument, it's based on sign. Like there's literally a sign. That's what a plaque is. So you look around and you see signs and they give you information and you have evidence that whatever the sign says is probably true, but it's not. Signs can be wrong. Okay, let's go on to some more. Number 3 here. The rainfall in Seattle has been more than 15 inches every year for the past 30 years. Therefore, conclusion indicator. So that tells us that the second statement is the conclusion. The first one is the premise. The rainfall next year will probably be more than 15 inches. Okay, so this is an argument based on data from the past. Something has happened repeatedly for 15 years. Therefore, it's likely that this pattern will continue. Likely, but will it be 100%? No, next year, Seattle might have a dry year, right? Droughts happen all the time, at least in California. So we could imagine that this can sometimes impact states to the north of us. So this is not a deductive argument. Even if it rained 15 or more inches for the last 1,000 years, still, that's not a guarantee that will happen next year. This is still, I think, a good argument, right? You might bet on it. So the odds might be, 80%, 90%. This is where statisticians and meteorologists, people who study rain, they could help us out with what the odds probably are. So number 3 is going to be inductive. What kind of inductive argument? It's a prediction. All right, I'll let you do 4 and 6 on your own. Let's do 8. The Matterhorn. So not the one in Disneyland. We're talking about the actual mountain that the ride in Disneyland is made after. The likeness thereof is higher than Mount Whitney, and Mount Whitney is higher than Mount Rainier. The obvious conclusion is that the Matterhorn is higher than Mount Rainier. Interesting. Okay, so this is saying, think of these as 3 things. We've got Matterhorn, Whitney, and Rainier. And we're saying the first thing is higher than the second thing, and the second thing is higher than the third thing. So naturally, we would conclude that the first thing is higher than the third thing. So if you think through this, the logic works out. Now, is this is the premise, and so this is a nice conclusion indicator. The obvious conclusion is, right, that's like one of the most plain conclusion indicators that there are, right? Here's the conclusion. Is this premise actually true? Well, that's an empirical question. So if you know facts about mountains, then you can say, oh yeah, this is actually true. But it might be false, but it doesn't matter. I mean, it does matter in one sense. So further on in the course, we will start to evaluate arguments. And what we'll learn is that there are 2 ways to tell if an argument is good, deductive or inductive, any type of argument. So one thing you'll do is you'll look at the inference, the logical relationship between the premises and the conclusion. Now, how do you evaluate an inference? Well, there's several ways. The easiest way is pretend all the premises are true. And if they are in fact true, then this makes this really easy. But if they're false, just imagine they're true. If they're a mixed bag, if there's multiple premises and some true, some false, just imagine they're all true, like I said. And if you're unsure, that's fine. Just for the sake of argument, grant that they're true. And then ask yourself, does the conclusion follow? And what do I mean by follow? Well, I mean, is it either, does it follow inductively? In terms of odds, are the odds greater than 50%? That would mean that the inference is good. And if the conclusion follows necessarily, as it does here, then we have a good deductive argument. And the inference in this case is one that we will say is valid. So that'll be a very important concept in this class that we'll study for weeks and weeks. So again, is this argument good overall? Well, it depends on the empirical question. Is this premise actually true? Maybe it turns out that Mount Whitney is higher than the Matterhorn. And it might be. I don't know. I'm not a mountain expert. But this is a deductive argument, because if we assume for the sake of argument that this is true, then this conclusion would be obvious. So this is a deductive. The conclusion follows necessarily from the premises. So if you grant the premises, then the conclusion has to follow. That is a deductive argument, and a special one that we'll say is valid. Okay, I hope that made sense. Let's go to 12 here. Either classical culture originated in Greece or it originated in Egypt. Classical culture did not originate in Egypt. Therefore, classical culture originated in Greece. See, here we have two premises. Let's see, in 8, we only had 1. In 3 and 2, we only had 1. So this is good. We're learning about arguments that have one premise and ones that have more than one premise. This is good to see different arguments with different amounts of premises. Okay, what do you think about this one? Well, it starts with this or statement, either this or that. Where was the origin of classical culture? Did classical culture originate in Greece, or did it originate in Egypt? The second premise says it did not originate in Egypt. So if it has to be one of these two, and again, for this, when we're evaluating the inference of an argument like we're doing here, we're just going to, for the sake of argument, we're just going to grant the premises. So we're going to assume that this first premise is true and that the other premise is true. And if we assume that, then classical culture must have originated in Greece, right? If it's Greece or Egypt and we rule out Egypt, then what's left? It's got to be Greece. So this is a deductive argument. And it's my understanding that it is a good deductive argument. I think that if so this is a kind of a bit of an empirical question, but it's more how historians have carved up history. And I think when they talk about the classical period, they're talking about Greece and maybe Rome, but Egypt, then you're going, that's a different age. That came many centuries before the ancient Greeks. So I think that this first premise actually is true. Again, even if it were false, it still would be a deductive argument. That wouldn't be a good deductive argument, but would still be deductive. And I also think the second premise happens to be true. But that, again, that's what you learn in your other classes, right? So if you combine the content of what you learn in other disciplines, other majors with logic, it's very, very powerful. You can do a lot of things. So 12 is deductive. And I won't go into this right now, but we'll learn about it in the future. A couple more. If Elon Musk is right about artificial intelligence, then artificial intelligence poses a risk to human survival. Okay, so this is an if-then statement. On this condition, grant this condition, this will follow. So if Musk is right, then AI, artificial intelligence, is a problem. and he is right, claims this second premise. Well, if these two premises are true, then what would follow? It would follow that AI poses a risk to human survival. So this is a deductive argument as well. Is it good? So you see how when we classify deductive, inductive, it doesn't matter if the argument is good or not, because you can have a good or bad deductive or inductive argument. So classifying it, my point is classifying the argument as deductive, inductive is one thing. And then figuring out if it's good or bad, that's another thing. And you can figure out the answer to the first disjunction or question without worrying about the second one. Is Musk right about artificial intelligence? That's a hard question to answer, right? That's kind of a question about the future. It's an empirical question, at least to a certain extent. And there's some vagueness here in this, what exactly, how much of a risk, like it'll annihilate us all, like the Matrix AI or Terminators. And then there's, well, AI is behind a lot of these algorithms and social media, and this is starting to pervert culture in ways that is not good for humanity. So there's a whole range of riskiness. So is it true? Well, it's almost partly empirical, partly philosophical, but the argument is deductive. Okay, and this last one. Crater Lake, the deepest lake in the United States, was caused by a huge volcanic eruption 7,700 years ago. Since human beings have lived around the mountain for more than 10,000 years, it is likely that people witnessed that eruption. So it is likely is a clue that this is inductive. You have to be careful. Phrases like that signal induction, but signal induction, probably inductive, but just be careful, because remember in one of the I think it was the first one, we saw this phrase, it must be the case. And that sounds like deduction, but it wasn't. All right. Again, so how do you tell? What's the test? Well, just ask yourself, if I grant these premises, does it guarantee the conclusion, or does it make it likely but not 100%? So assume that Crater Lake is the deepest lake in the United States. Again, if you're a lake expert, then you can confirm this, and assume that it was caused by this eruption 7,700 years ago. Assume further that human beings have lived around the mountain for more than 10,000 years. I don't know if that's true. Some of you might, which is awesome. But if you assume both of these things, would it be likely that people witnessed the eruption? Well, if people lived around there during the time that it happened, okay, it's a fair bet that they saw it. Is it a guarantee? No. So we can rule out deduction. So we're left with induction. It's an inductive argument. So it's an example of induction. We could say it that way. All right. Wonderful. Wonderful, wonderful. I hope that made sense. So that was, I already forgot what section that was. That was 131. All right. So let's learn a little bit more, practice a little bit more, and then we'll call it for this video lecture. In 1.4, validity, truth, soundness, strength, cogency is discussed. So let's get into it. Actually, you know what? I'm gonna just stop this video and make a new one, just so it'll be more digestible. And maybe I won't even, maybe I'll edit out this part. We'll see.